Hello everyone, welcome to concept classes. So in this video, I am going to discuss important algebraic expression. So if you are a student of class 9th and 10th, this video is going to be very important for you because you will definitely use these identities during your maths course. So without wasting time, let us start. So the first identity is a plus b whole square. So a plus b whole square is equals to a square plus b square plus 2 times ab. So let us take an example to clear this identity. So we have x plus 7 whole square. So you can take x as a and 7 as b. So a plus b whole square, as you know, is a square. So a means here your a is x, so x square plus b square. Here b is your 7 plus 2 times ab. So a is your x and b is your 7. So now we have x square plus 7 square is 7 times 7, which is 49, plus 7 to the 14x. So this is x square plus 49 plus 14x. So let us take another example, 2x minus 4 to the whole square. So here you can take 2x as a and 4 as b. So a square means 2x square plus b square means 4 square plus 2 times ab. So a is your 2x and b is your 4. So now squaring 2 is 4 and x square is x square plus 4 square is 16 plus 4 to the 8, 8 to the 16. So 16x. So the first identity is a plus b to the whole square, which is equal to a square plus b square plus 2 times ab. So now let us move to the next identity, which is a minus b whole square. So a minus b whole square is a square plus b square minus 2ab. So the main difference between these two identities, the minus sign before 2ab. So let us take an example to clarify this identity. X minus 6 to the whole square. So here a is your x and b is your 6. So a square means x square plus b square means 6 square minus 2 times ab. So a is your x and b is your 6. So now x square plus 6 square is 36, then minus 6 to the 12 times x. So this is the simplified form of x minus 6 to the whole square. So let us take another example, 4x minus 5 whole square. So here a is your 4x and b is your 5. So a square means 4x square, b square means 5 square minus 2 times ab. So a is your 4x and b is your 5. Now square 4 is 16, then we have x square plus 5 square is 25, then we have minus, then 4 5s are 20, 20 to the 40 and x. So this is the simplified form of 4x minus 5 to the whole square. So hope you understand the identity. So now move to the next identity. This is one of the important identity which you will definitely use during your 10th maths course. So this is a minus, this is a square minus b square. So a square minus b square is written as a plus b times a minus b. So whenever you see such type of form, a square minus b square, you have to simplify it in the form as a plus b times a minus b. So let us take an example. We have x square minus 6 square. So we can write x square minus 6 square as x plus 6 or x minus 6, because here our a square is x square and our b square is 6 square. So now let us take another example, 4x square minus 36. So we can write 4 as 2 square and x square is written as x square. So we can write 4x square as 2x square. Then we have 36. So 36 is the square of 6. So we can write 4x square minus 36 as 2x square minus 6 square. So now this became the identity of a square minus b square. So here our a is 2x and our b is 6. So we can write this as 2x plus 6 or 2s minus 6. So now next identity, a plus b square minus a minus b square. So this identity equals to 4 times ab. So now let us see the proof of this identity, how we get 4ab. So we have a plus b whole square minus a minus b whole square. So a plus b whole square, as you know, is a square plus b square plus 2ab. This is the first identity. Now then minus sign, then a minus b square is a square plus b square minus 2ab. So now opening the bracket, we have a square b square 2ab. This is as it is. Then minus change the sign, minus a square plus minus b square minus minus plus 2ab. Now cancelling the term, so a square cancel with a square, b square cancels with b square because they have opposite sign and they have same value. So now only what remains? 2ab plus 2ab. So 2ab plus 2ab is 4ab. So a plus b whole square minus a minus b whole square is equals to 4ab. So now let us move to the next identity. So this identity is a plus b whole square plus a minus b whole square. So this equals to 2 times a plus b whole square. So now let us see the proof of this identity. So a plus b whole square plus a minus b whole square equals to, now putting the identity of a plus b whole square, which is a square plus b square plus 2ab. Then we have plus sign. Now using the identity a minus b square here, so a square plus b square minus 2ab. Now just open the bracket. So we have 2ab cancels with 2ab because they have same value and different sign, so they cancels each other. Now what remains? A square plus a square, so it means 2a square, and we have b square plus b square, which is 2b squares. Now take 2 common from this, we get 2 times a square plus b square. Okay, so now let us move to the next identity, a plus b whole cube. So a plus b whole cube is equals to a cube plus b cube plus 3ab times a plus b. So this is also one of the most important algebraic identity and you should memorize this. So now let us see the proof of this identity. So a plus b whole cube, we can write a plus b whole cube as a plus b whole square times a plus b, because as you know the power of a plus b here is 2 and the power of a plus b here is 1. So 2 plus 1 means 3. So we can split a plus b cube as a plus b square times a plus b. So now using the identity a plus b whole square, which is a square plus b square plus 2ab times a plus b. Okay, so now we have, now multiply a square with a plus b, then b square with a plus b, then 2ab with a plus b. So when we multiply a square with a, we get a cube. When we multiply a square with b, we get a square b. When we multiply b square with a, we get b square a. When we multiply b square with b, we get b cube. When we multiply 2ab with a, we get 2a square b. When we multiply 2ab with b, we get 2ab square. So now adding similar terms, so we have 2ab square and we have ab square, so 3ab square. Similarly we have 2a square b plus we have a square b, so 3a square b, and a cube and b cube remains as it is. So now we have a cube plus b cube. Now take 3ab common from these two terms, so we get 3ab bracket a plus b. So whenever you see a plus b cube, always write it in the form as a cube plus b cube plus 3ab bracket a plus b. So now next identity, a minus b cube. So a minus b cube is a cube minus b cube minus 3ab times a minus b. So now let us see the proof. The proof is similar like the previous one. So a minus b cube is written as a minus b square times a minus b. So now a minus b square is a square plus b square minus 2ab. And we have a minus b. Now multiply a square with a minus b, then b square with a minus b, then minus 2ab with a minus b. So when we multiply a square with a, we get a cube. A square with minus b, we get minus a square b. B square with a, we get b square a. B square with minus b, we get b cube. In the similar way, we can multiply the remaining terms, and then a cube, we have b cube. Then you see here minus 2 square minus 2a square b, here minus a square b, so it becomes minus 3a square b, and here plus 2ab square plus ab square, so you get 3ab square. So it's simply algebra, you can add the similar terms. And then we have a cube minus b cube. Now taking common minus 3ab from these two terms, so after taking common minus 3ab from these two terms, what we get? A cube minus b cube minus 3ab bracket a minus b. Okay, so now move to the next identity. This is also one of the most important identities. So a cube plus b cube. So a cube plus b cube is written as a plus b times a square plus b square minus ab. Okay, so whenever you see a cube plus b cube, always write it in the form a plus b times a square plus b square minus ab. So now let us see the proof. So in doing the proof, what we do, we will make right hand side equals to left hand side. Okay, so first what we do, we will take right hand side of this equation, we will solve it, and we will make it equal to left hand side. Okay, so you can see this is the right hand side of this equation, which is a plus b times a square plus b square minus ab. So now multiply a with all these three terms, then multiply b with all these three terms. So what we get, a cube plus ab square minus a square b plus ba square plus b cube minus ab square. Okay, now cancelling the similar term, you can see here minus a square b, and you can see here plus a square b. So these two terms cancel out. In the similar way, here plus ab square, here minus ab square. So these two terms also cancel out. What you get, a cube plus b cube. Okay, so this is the proof of this identity. Now let us take an example. We have x cube plus 64. So x cube plus 64, you know 64 is written as 4 cube, because 4 times 4 times 4 is 64. So you can write 64 as 4 cube. So we have x cube plus 4 cube. So now take the identity, use the identity, a cube plus b cube as a plus b. So here a is x and b is your 4. So x plus 4 times a square means x square plus b square means 4 square, which is 16, minus ab, which is 4x. So I think you understand the identity. Now move to the last identity. Again, this is also most important. So a cube minus b cube. So a cube minus b cube is written as a minus b times a square plus b square plus ab. So now let us see the proof. Again, we will make the right hand side equals to left hand side. So in the right hand side, what we have a minus b times a square plus b square plus ab. Multiplying all these terms, you know how to multiply. So we get a cube plus ab square plus a square b minus ba square minus b cube minus ab square. So now cancelling the similar terms with opposite sign, what you get, a cube minus b cube. Okay, so let us take an example. So we have x cube minus 8. So in order to make this equation similar to this form, what we will do, we will write 8 as 2 cube. Okay, so we have x cube minus 2 cube. So x cube minus 2 cube is equals to x minus 2, because we have a minus b. Then a square means x square, then b square means 2 square, which is 4, then plus ab, which is 2x. Okay, so these all identities are very important. If you are studying math in your 9th or 10th class, you will definitely use in your trigonometry, in your quadratic equation, your coordinate geometry. Whenever you solve any type of problem, always you will see some type of quadratic equation and such type of algebraic equation. So I just recommend you to memorize all these formulas. Thanks for watching the video.